Hi friends, welcome to the dj.anshi YouTube channel. Today we are going to discussing the concept of Legendre's linear differential equations. The standard form of the Legendre's differential equation is a naught ax plus b whole power n dny by dx power n plus a1 ax plus b whole power n minus 1 into d power n minus 1 into y by dx power n minus 1 plus up to so on a n y which equal to f of x. This is the standard form of the Legendre's differential equations. The differential equation of the form a naught ax plus b whole cube d cube y by dx cube plus a1 ax plus b whole square d square y by dx square plus a2 ax plus b dy by dx plus up to so on a cube y which is equal to f of x. Put ax plus b is equal to e power t. This is the Legendre differential equations. To solve this, we put ax plus b is equal to e power t or t is equal to log of ax plus b. Differentiate with respect to x, you get dt by dx which is equal to 1 by ax plus b. This is the differentiation of log of ax plus b into chain rule. Ax plus b differentiation is a, and dy by dx which equal to dy by dx can be written as dy by dt into dt by dx. Okay, so dy by dt is as it is. Dt by dx is a by ax plus b, a by ax plus b. So this ax plus b can you multiplied to left hand side, so you get ax plus b into dy by dx which is equal to a dy by dt. So you write d by dt by capital letter D, you get ax plus b into dy by dx which is equal to a dy. Similarly, ax plus b whole square d square y by dx square can be written as a square into d minus 1 into y, and ax plus b whole cube d cube y by dx cube can be written as a cube into d minus 1 into d minus 2 into y. In the same way, we can substitute for higher order terms. When we substitute this, the equations reduce us to differential equations with constant coefficients. Okay, let me move on to the problems. Through the problems, you can understand easily. The problem number 1, solve 1 plus x whole square d square y by dx square plus 1 plus x dy by dx plus y which is equal to 4 cos log of 1 plus x. Is of the form ax plus b whole square d square y by dx square plus ax plus b into dy by dx plus y which is equal to 4 cos log of 1 plus x. This is the Legendre differential equations. So you put 1 plus x which is equal to e power t or t is equal to log of 1 plus x for solve the Legendre differential equations. Okay, so what you get, 1 plus x dy by dx can be written as 1 into d into y, because ax plus b dy by dx can be written as a into dy. A, what is a value? A value is 1. Similarly, ax plus b whole square d square y by dx square can be written as a square into d minus 1 into y. Okay, so in this case we use the a value is 1, so you put a square value is 1. Okay, x plus 1 whole square d square y by dx square can be written as 1 into d minus 1 into y. Okay, substitute these to the Legendre equation. So we get 1 plus x whole square d square y dx square is d into d minus 1 into y plus 1 plus x dy by dx is dy plus y which is equal to 4 cos log of 1 plus x is t. So 4 cos t. In the next step, you take y in the outside, you get d square minus d plus 1 into y which is equal to 4 cos t. You get d square plus 1 into y which is equal to 4 cos t. Okay, let us consider pi of d is equal to 0. What is pi of d? Pi of d is d square plus 1 which is equal to 0. For finding the complementary function, we replace d by m. We get m square plus 1 which is equal to 0. So m is equal to plus or minus I. We get the imaginary roots, the complementary function which is equal to c1 cos t plus c2 sin t. Then we find the particular integral which is equal to 1 by pi of d into f of t. 1 by pi of d is d square plus 1 into f of t is 4 cos t. So is of the form cos ax format alide. We replace d square by minus a square. We replace d square by minus a square. A value is 1, so we replace d square by minus 1. If you replace d square by minus 1, you get 0 in the denominator, hence the case is fails. So you multiply t and differentiation of pi of d, you get 4t cos t by differentiation of d square plus 1 is 2d. Okay, which equal to 1 by d cos t. 1 by d cos t is nothing but integration of cos t. Integration of cos t is sin t. You get 2t sin t. Therefore, the particular integral which is equal to 2t sin t. So, the general solution which is equal to the complementary functions plus particular integrals. You adding both complementary functions and particular integrals and then substitutes t value. Okay, c1 into cos t is log of 1 plus x. T is log of 1 plus x plus c2 sin t is log of 1 plus x plus 2 log of t means log of 1 plus x into sin of t means log of 1 plus x. That's about the general solution. Okay, let me move on to the second problem. Solve x plus 1 whole square y double dash plus x plus 1 y dash plus y which is equal to 2 sin of log of x plus 1. It is the Legendre differential equation. Okay, put x plus 1 which is equal to e power t or t is equal to log of x plus 1. Okay, y double dash is nothing but d square y by dx square. Y dash is dy by dx. Okay, is of the form ax plus b whole square d square y by dx square can be written as a square into d minus 1 into y. A value is 1, so you get d into d minus 1 into y plus ax plus b dy by dx is nothing but a into dy. A value is 1, so you get dy plus y which is equal to 2 sin log of x plus 1 is nothing but t. Okay, 2 sin t agutte. So after the solving of this equation, you get d square plus 1 into y which is equal to 2 sin t. Let us consider pi of d is equal to 0 for finding the complementary function. You get d square plus 1 which is equal to 0. Put d is equal to m. You get m square plus 1 is equal to 0. You get the imaginary roots. So the complementary function which is equal to c1 cos t plus c2 sin t. So then we find the particular integral which is equal to 1 by pi of d into f of t. 1 by pi of d is d square plus 1 into f of t is 2 sin t is of the form sin ax format alide. You replace d square by minus a square. A value is minus 1. If you replace d by minus 1, you get 0 in the denominator, hence the case is fails. So the particular integrals find out mododike, you multiply t in the numerator and differentiate the denominator. Okay, so you get a 2t by d square plus 1 differentiation is 2d into sin t is as it is. So 1 by d sin t is nothing but integration of sin t. Integration of sin t is minus cos t. T is as it is, 2 get cancelled. So the particular integral which is equal to minus t cos t. Okay, the general solution which is equal to the complementary functions plus particular integrals. You adding both complementary functions and the particular integrals, then you get y is equal to c1 cos t is log of x plus 1 plus c2 sin t is nothing but sin t means log of x plus 1 minus plus into minus minus t antandre log of x plus 1 cos log of x plus 1. That's about the general solutions. Next we move on to the next problem. Solve x minus 1 whole cube y triple dash plus 2 x minus 1 whole square y double dash minus 4 x minus 1 y dash plus 4y which is equal to log of x minus 1. So it is the Legendre differential equation. You put x minus 1 which is equal to e power t or t is equal to log of x minus 1 to solve the Legendre differential equations. So look here, x minus 1 whole cube y triple dash is nothing but is of the form ax plus b whole power cube d cube y by dx cube. It can be written as a cube into d minus 1 into d minus 2 into y. A value is 1, ax ide, so a value is 1, you get d into d minus 1 into d minus 2 into y plus 2 into is of the form ax plus b whole square d square y by dx square. So a value is 1, you get 2 into 2 is as it is, this can be written as d into d minus 1 into y minus 4 into x minus 1 y dash is nothing but dy plus 4y is as it is, which is equal to 4 log of x minus 1 is nothing but t. You solve these equations, finally you get d cube minus d square minus 4d plus 4 into y which is equal to 4t. Let us consider pi of d is equal to 0 for finding the complementary functions. So pi of d is d cube minus d square minus 4d plus 4 which is equal to 0. You put d is equal to m, you get m cube minus m square minus 4m plus 4 which is equal to 0. You solve this, you get 3 different roots. m1 is equal to 1, m2 is equal to 2, m3 is equal to minus 2. So the complementary function which is equal to c1 e to the power t plus c2 e to the power 2t plus c3 e to the power minus 2t. Next we want to find the particular integral. Particular integral which is equal to 1 by pi of d into f of t, which is equal to 1 by pi of d is d cube minus d square minus 4d plus 4 into f of t is 4t. Is of the form x power m ಫಾರ್ಮ್ಯಾಟ್ಸ್ ಅಲ್ಲಿ ಇದೆ. x power m ಫಾರ್ಮ್ಯಾಟ್ಸ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂತಂದ್ರೆ we take constant term in the denominator, next inverse ಮಾಡಬೇಕು. 4 is the constant term, you take 4 in the outside, you get d cube by 4 minus d square by 4 minus d plus 1. Okay, so 4 get cancelled. This can be written as 1 plus d cube minus d square minus 4d by 4 whole inverse into t. T can be differentiated only one time, so the signs will be the difference. So you write 1 minus d cube minus d square minus 4d by 4 into t. It can be written as 1 minus into minus plus 4d by 4 into t. 4 get cancelled, you get 1 plus d into t. So you multiply this t plus dt means differentiation of t, you get 1. So the particular integral which is equal to t plus 1. The general solution which is equal to the complementary functions plus particular integrals. So you add both complementary functions and the particular integrals, then substitutes t and e power t values. Okay, so c1 y is equal to c1 into e power t means x minus 1 plus c2 into e power 2t means x minus 1 whole square plus c3 e power minus 2t can be written as 1 by e power 2t. E power 2t means x minus 1 whole square plus t means log of x minus 1 plus 1. That's about the general solution. Okay. Fourth problem. Solve 3x plus 2 whole square d square y by dx square plus 3 into 3x plus 2 dy by dx minus 36y which is equal to 8x square plus 4x plus 1. Put 3x plus 2 which is equal to e power t or t is equal to log of 3x plus 2 because it is the Legendre differential equation. Okay. 3x plus 2 whole square d square y by dx square is of the form ax plus b whole square d square y by dx square. which equal to a square into d minus 1 into y. A value is 3, you get 3 square into d minus 1 into y. 3 square is 9. So 9 into d minus 1 into y. 3x plus 2 whole square d square by dx square can be written as 9d into d minus 1 into y. Then 3x plus 2 dy by dx which equal to is of the form ax plus b into dy by dx which equal to a into dy. A into dy. A value is 3. You put 3x plus 2 dy by dx can be written as 3 dy. Then 3x plus 2 which equal to e power t. What about x value? X value which equal to e power t minus 2 by 3. You substitute all those values to the Legendre equation. You finally get 9d d minus 1 into y plus 3 into 3 dy minus 36y which equal to 8 into x value is e power t minus 2 by 3 whole square plus 4 into x value is e power t minus 2 by 3 plus 1. So finally you solve this, you get 9d square minus 4 into y which is equal to 8 e power 2t plus 32 minus 32 e power t plus 12 e power t minus 24 plus 9. Then you get a d square minus 4 into y which is equal to 8 e power 2t minus 20 e power t plus 17 by 81. Let us consider pi of d is equal to 0 for finding the complementary function. So pi of d is d square minus 4 which is equal to 0. You substitute d by m. Then you get a difference roots. So the complementary function is equal to c1 e to the power 2t plus c2 e to the power minus 2t. So what about the particular integral? Particular integral which is equal to 1 by pi of d into f of t which is equal to 1 by pi of d is d square minus 4 into f of t is 1 by 81 into 8 e power 2t minus 20 e power t plus 17. You multiply d square minus 4 to all these terms, you get 1 by 81 into 8 by d square minus 4 e power 2t minus 20 d square minus 4 into e power t plus 17 e power 0t. E power 0t is nothing but 1. Okay, by d square minus 4 is of the form e power ax. E power ax formats alli ittu antandre you replace d by a value is 2, then you get a 1 by 81 8t 2d e power 2t minus 20. You replace a value is 1. In this case you get minus 3 into e power t plus 17. You replace 0, you get minus 4. Finally you get a 1 by 81 2t e power 2t plus 20 by 3 e power t minus 17 by 4. That's about the particular integral. Next we find the general solution. General solution which is equal to the complementary functions plus particular integrals. You adding both complementary functions and the particular integrals, then substitutes e power t and t value. So y which is equal to c1 into e power 2t. E power 2t is 3x plus 2 whole square plus c2 e power minus 2t. E power minus 2t can be written as 1 by e power 2t. 1 by e power 2t is 3x plus 2 whole square plus 1 by 81 into 2 into t is log of 3x plus 2 into e power 2t means 3x plus 2 whole square plus 20 by 3 e power t means 3x plus 2 minus 17 by 4. That's about the general solutions. Let me move on to the next problem. Solve 2x plus 1 whole square y double dash minus 2 into 2x plus 1 y dash minus 12y which is equal to 6x. This is the Legendre differential equations. To solve this, put 2x plus 1 which is equal to e power t, or t is equal to log of 2x plus 1. So what about x value? X value which is equal to e power t minus 1 by 2. Okay. 2x plus 1 whole square y double dash can be written as 2 square into d minus 1 into y, because is of the form ax plus b whole square into d square y by dx square. It can be written as a square into d minus 1 into y. So finally you get 4d into d minus 1 into y. So 2x plus 1 whole square y double dash can be written as 4d into d minus 1 into y. So next 2x plus 1 y dash can be written as 2 dy. 2 dy. Substitutes these values to the Legendre equation. You get 4d into d minus 1 into y minus 2 into 2 dy minus 12y which is equal to 6. X value is e power t minus 1 by 2. Okay, so you solve this, you get d square minus 2d minus 3 into y which is equal to 3 by 4 into e power t minus 1. Let us consider pi of d is equal to 0 for finding the complementary function. So what is pi of d? Pi of d is d square minus 2d minus 3 which is equal to 0. You replace d by m, you get m square minus 2m minus 3 is equal to 0. So you simplify this, you get difference roots. So the complementary function which is equal to c1 e power minus t plus c2 e power 3t. What about the particular integral? Particular integral which is equal to 1 by pi of d into f of t which is equal to 1 by pi of d is d square minus 2d minus 3 into f of t is 3 by 4 into t minus 1. So you multiply d square minus 2d minus 3 to this term, you get 3 by 4 into e power t into d square minus 2d minus 3 minus 1 into e power 0t into d square minus 2d minus 3 is of the form e power ax format alide. So we replace d by a value is 1 to this one is of, in this case d is replaced by 0. So you get 3 by 4 into e power t by minus 4 minus 1 by minus 3. Finally you get particular integral which is equal to 3 by 4 into 1 by 3 minus e power t by 4. So the general solution is equal to the complementary functions plus particular integral. Complementary function is c1 e power minus t plus c2 e power 3t plus particular integral is 3 by 4 into 1 by 3 minus e power t by 4. Then substitutes e power t value. Finally you get y is equal to c1 by e power minus t can be written as 1 by e power t. E power t value is 2x plus 1 plus c2 into e power 3t means 2x plus 1 whole cube plus 3 by 4 into 1 by 3 into minus e power t is 2x plus 1 by 4. That's about the general solutions. If you have any doubts regarding this concept, please ask me in the comment section. Let me know you understood or not. Please mention it in comment box. If you like a video, please like, comment, share and also subscribe.